going to talk about non-trivial aspects of NIBP testing, and I think you're going to find some interesting things, maybe some things you didn't know or didn't think about. Let's go to the next slide, Mike. What we're going to cover is just a review of blood pressure, what causes it, what is it, a little bit about monitoring non-invasive blood pressure, and then we're going to go into non-invasive blood pressure performance testing. So these are all really important to get right in order to make sure that any medical device, any patient monitor that includes non-invasive blood pressure, NIBP, is functional and we have objective independent evidence of that performance. Go ahead, Mike. Okay, let's start with the basics. Blood pressure is the product, mathematically, the product of the flow of the blood multiplied by the resistance in the blood vessels. So they're expressed, blood pressure, as you may well know or may not know, is expressed in one number over another number. The top number is systolic pressure. That's the pressure in the arteries when the heart contracts. And the bottom number is the diastolic pressure, which is the pressure in the arteries when the heart refills and is at rest. So just make sure that you have that kind of straight in your head when you're thinking about NIBP. The clinical part of this is really important. It's not all just technology. It's a technology that we use in order to obtain this measurement. Okay, go ahead, Mike.
Before we move on, do you want to touch quickly on how blood pressure is generated?
Yes, so when the heart pumps in the arteries, the blood flows with a force pushing against the walls of the arteries, and the blood pressure is the product of the flow of the blood times the resistance in the blood vessels. The same kind of occurs in the diastolic, that is where the heart is refilling, but the diastolic pressure is lower, of course, lower.
All right, thanks.
So starting with the basics, kind of continuing, here's a little bit of information about what you should expect is a normal blood pressure, elevated blood pressure, high blood pressure, very high blood pressure. And the numbers that are shown are, they're not hard and fast rules. They're not cut in stone. They are approximations that have been agreed about by doctors and nurses who publish in peer review journals. So these are kind of ranges that doctors understand. So doctors understand, what does it mean? What does the pressure measurement that they just took mean? So 120 over 80 seems to be fairly normal, but not everybody is 120 over 80. 120 over 129 would mean an elevated blood pressure, and 120 over more than 80 is elevated. 130 to 139 over 80 or 89 would definitely be high blood pressure. That would be how it would be categorized. Very high blood pressure would be anything greater than 140 over 90, and these units of measure here are millimeters of mercury. In other clinical settings around the world, the units of measure may be kilopascals, and therefore the numbers are going to be a little bit different because they will be in kPa. It's rare that we see anything other than millimeters of mercury or kPa anywhere in the world where we're measuring blood pressure. So this kind of gives you a little bit of a perspective. By the way, the blood pressures that are significantly below 120 over 80 are low blood pressure, and that's another clinical red flag. The doctor's going to want to drill down and figure out what is going on. Why is your blood pressure so low? Okay, go ahead, Mike.
Do we want to talk about anything that any of the warning signs that kind of come with blood pressure?
Actually, this is really important. So as we get into the elevated, high, and very high, the concern here is that this high blood pressure over a long period of time is going to do damage to the blood vessels and therefore to other cells in the body. So it's not limited to just heart attacks that can occur, or heart failure or strokes or kidney failure. These are all examples. Peripheral arterial disease. These are examples. They're not only caused by high blood pressure, but high blood pressure is a strong indicator that some of these things may also be occurring. And that's why the doctor will drill down to find out why blood pressure is higher than it should be or lower than it should be. If you're a type 2 diabetic, you may also have blood pressure issues that your doctor is going to want to track and may recommend that you make measurements with a home care blood pressure device just to get a trend. Is your blood pressure moving upwards, or is it moving downwards, or is it staying relatively the same?
Yeah, so the only way to really determine whether or not you have high blood pressure is to get it checked and to get it checked regularly.
Exactly. And oh, by the way, there in most pharmacies, they have a little blood pressure machine. You can sit down there and it'll take your blood pressure measurements. So you don't even need to own a blood pressure device if you're trying to take care of yourself. You could go to the pharmacy and they should have one. But there are home care devices too. I have one, for example.
All right, so you
Mhm,
talked about some of those automatic NIBP measurements, right, that you
mhm.
would get taken at one of those facilities. But what I do want to touch on here is what would happen if it was wrong, right? So there are two measures here, right? There's a oscillometric and there's a scrutulatory, and both of these they both measure non-invasive blood pressure. One is much more manual and the other is automated, but what Jerry just talked about is the importance of measuring it correctly, right? And these can have errors, and they do have errors, and they can lead to misdiagnosis or mistreatment. So if something is wrong or it's suspected to be wrong, what could be done, right? So what should the doctor or nurse do? The first thing to do is think about the patient. Make sure that they continue to be the focus. So if you're using something that is automated, you might want to shift to the more manual method of measuring NIBP to see if you get the same result. Troubleshooting, right? If there's a difference here, you want to take out the stethoscope, listen, see if there's a difference, and then you'll know, at least isolate the error to the cuff, right? The automated method, right? If that doesn't work, if you're getting the same reading, you might want to switch cuffs, right? So use a different cuff on the same arm for that patient and see if that changes anything, because then you could isolate the change to the cuff. So basic troubleshooting occurs here, but you want to make sure that that patient gets the right reading. And of course, if anything goes wrong, what you should do is report that NIBP device to Biomed. Because in some way, shape, or form, it didn't work right the first time, and it does need to get looked at. So these are kind of errors that are right in the forefront in terms of, something that you can sense, you can feel, you can see. But what if the error didn't get caught? And that's what we want to talk about here. There's errors in use that can give you an incorrect reading. And these are things that clinicians can do, and they may or may not be aware of the fact that they're doing them. So it's really important for you guys to know this so that you can troubleshoot with them while you have them on the phone. One is using the wrong sized cuff. This can happen frequently. There are different sized cuffs, and we have to make sure we use the right size for the right patient. The patient can be positioned incorrectly, right? Or the cuff on the patient. Those are two things that you can help troubleshoot from the Biomed shop to try and see if you can get a better reading. And then there's a normal reading prejudice, right? So everyone tends to see what they want to see and not what's actually there. And the other thing is not factoring in electronic units correctly. Now, when you think about these, you have your automated test devices, you have your manual test devices. That's one way to troubleshoot, and that's one thing you can instruct your clinicians to do. The other thing is they might have the actual units incorrect. Jerry brought up kilopascals. Are they just looking at the wrong units? And that's what's driving the incorrect numbers to be there on the screen. The long and short of it is everything we've just gone through is preventable or addressable by the clinical staff, right? If you and the clinical staff have worked through this and the error still persists, then you guys need to be brought in to replace either a durable good and or come up and troubleshoot the device further. And I really want to hit on the fact that correct NIBP measurements are critical measurements for patient diagnosis. And I really want to push this partnership between the clinical staff and biomed. Everyone's on point to get the right reading. So it could be the things that are on the screen here. But again, there's a partnership here that you guys can help facilitate to prevent work for yourselves, because a lot of these can be caused by the clinical staff themselves.
Yeah, so here's a couple of tips. Wrong size cuff. Well, what do we mean by that? Let me give you a concrete example. Normally, there's an index indicator in the cuff. As you wrap the cuff, one end is supposed to wrap to the other end, not fall short, not overlap. So the difficulty is we have lots of different size patients with different size biceps, arms, with different size thighs. And so there's this cuff called a long adult cuff. Well, the long adult cuff may need to be used for someone with a really large bicep. Same thing with the thigh cuff. However, the volumetric capacity for that cuff is different than the adult cuff, which is the basis for the NIBP measurement and the design of the medical device. So if you're using that long adult cuff inappropriately, sometimes it's just because that was the only cuff the nurse could find. It's going to give you wrong measurements. So you got to be careful about that. Secondarily, if they don't trust the oscillometric, the automated NIBP measurement, and they're going to take an auscultated measurement, they need to do it on the same limb, the same arm, the same leg, not the other side of the body, because the blood pressures are different, and they're different from measurement to measurement. So you don't want to take one measurement and then take another measurement on a different limb at a different time. That's not going to resolve the conflict or give more trust in the measurement. So what do? Well, here's what I had done. And remember, I've got over 40 years in the field, 10 of which were doing what you do in the hospital, working with doctors and nurses all the time. I had the clinician, doctor or nurse or even paramedic, put their stethoscope on the artery that's being occluded. So if it was a bicep, then that's going to be the brachial artery right near the elbow, in the crook of the elbow. And I want them to listen while the automatic blood pressure measurement is being made, and listen for their carot cough sounds, because that's what's going to give them their systolic and diastolic, and they'll calculate the mean pressure from that. 9 times out of 10, that gave them the trust in the measurement that the automated unit was making. Sometimes it didn't. And as Mike said, that's the time when you say, okay, there's really something wrong going on here. Is it a leak? Let's try a different same size cuff, okay? And then repeat the exercise. If at the end of that, it's still not giving the right readings, then it's time to take the NIBP device, could be the whole patient monitor, to the shop or wherever you can actually do the work to troubleshoot it. So those are kind of some tips around how we help the clinicians get the right measurements, because they really do matter in terms of diagnosis, because the misdiagnosis and improper treatment puts the patient at higher risk, either of injury or inappropriate treatment may cause the patient to not go home on time. And that means the cost of care is higher, which affects the hospital's bottom line, which affects your paycheck. So just think about these things and trying to think it through and work it through in a logical way. The clinical side of this stuff matters, and it's good for you to understand it.
Absolutely. All right, so with that, let's move on to the first poll question. So the question here is, what important pressure functions of NIBP devices need to be tested? And there are going to be multiple answers here. So is it a system leak test? Is it a pressure relief test? Or is it an accuracy test? And why don't you kick us off with the poll?
All righty. So responses are coming in, Mike. Good question. And
See what comes out of it.
Yeah, absolutely. I'll give attendees another 20 seconds before we close the poll. I'm counting down. Responses are coming in. Okay, looking good here, Mike.
All right.
All righty, so we're going to go ahead and close the poll. The poll is now closed, and I'll share the results. Wow. So 69% indicated system leak tests, 56% indicated pressure relief tests, and 74% indicated accuracy tests.
All right. Well, I'll reveal the answer here, which is all of them. So all three of these tests are needed. So for those of you that that selected A, B, and C, you need to make sure you're testing all the pressure functions of an NIBP device to make sure that it is indeed ready for clinical use and it is going to give the best diagnosis and ensure the best treatment for that patient. So any one of these tests a portion of it, but the only way to test the entire device is to do all three.
And in fact, the sequence that we have these responses in is the right sequence to think about in doing the testing for NIBP. First, make sure that the system doesn't have leaks, because if it has leaks, you're not going to be able to get the right measurement. You'll get an incomplete measurement. So leak-free or as close to it as possible, because all pneumatic systems leak. They do. But as long as the leak rate is within the acceptable range, that's good. The next thing is the most important test that we can do on NIBP is the pressure relief test. At what pressure does the relief valve open and vent the cuff so that it depressurizes? We don't want to have a super high pressure occluding the blood vessels for a very long time. It hurts the patient, number one. And so we don't want to do that. And secondarily, it can do actual tissue damage. So the pressure relief test trip point is the next test that needs to be done. Once we're done testing those two things, and by the way, the pressure relief test and the accuracy test are have to be done in the service mode for NIBP on the patient monitor, because you have to be able to control the relief valve. It has to be closed in order to pressurize anything. So the pressure relief test will have some pressure at which it trips, and you're going to compare that to the manufacturer's specification for where that trip point should be. The accuracy test is a series, not just one, but a series of static pressure level comparisons. So you'll pressurize the system. Probably the NIBP system wants to be the source of the pressure, and that's fine. That means that your test instrument is being a digital pressure meter that's measuring and comparing, that you can compare your NIBP display against for these static pressure levels. Your test instrument is always going to be more accurate than the patient monitor, than the NIBP device itself. So trust your test instrument and keep it in calibration. So you're going to compare a series of measurements. Sometimes those are specified by the manufacturer in the service manual test procedure, and sometimes they only do 1 or 2 pressure settings. You may choose to do more depending on what your experience is with the NIBP devices that you're measuring, okay, with that brand and model. So make sure that you're testing not just what the manufacturer is saying, but also maybe some additional pressures if you've been having trouble and failures, okay? But those all require that we be in the service mode, that we can control the relief valve so we can actually pressurize the system.
All right, thanks, Sherry. So we're going to try something new. We're going to jump right into a second poll question, which is what size cuff should be used when doing NIBP testing? This one has a few options as well. We have the standard adult size, the long adult size, and the thigh cuff size. So Edna, if you'd launch that poll, we'll see how those answers come in for this question. And I don't see the window for the poll popped up. There it is.
Right.
Perfect.
All right, it is pulled up. I'm going to do this one for you, Mike.
Perfect.
Great. The answers are, people are, all right, I'm going to give you about 15 more seconds on this, and then we'll go ahead and close the poll and show the results here. We have about 71% voted, so get your votes in there. About 5 more seconds here. All right, I'm going to go ahead and close it and share the results. So 93% voted adult, standard adult size, and then we had 3% and 4% on the other two.
So
All
good
right.
job, everybody. Very good job. Go ahead, Mike.
Yep. Just highlighting the right answer there. 93% of you got that right. The standard adult size is what should be used. And Jerry, sorry, I cut you off.
Right.
Feel free to
No, that's
elaborate.
okay. I expected you to. The people that answered long adult size and thigh cuff size, the experience that you in the hospital that you're working in, or the clients that you have, if you're a field service engineer, may cause you to want to test the other size cuffs as well, and that's fine. But the standard adult size has got to be tested. Another thing that some of you may have been looking for is an option called for infant cuffs, because infant cuffs are very small, but not every NIBP device is capable of NIBP measurements on infants. So if you have an NIBP device that also has an infant mode, then yes, you definitely should test the infant size cuff, and the predominant one, or the one that's specified in the brand and model specific test procedure from that manufacturer.
All right. So with this, I wanted to get a little bit into the oscillometric method, and specifically the algorithm that's used. So when it comes to measuring blood pressure, there are 2 algorithms that are used. There's the height method and the slope method. So with the height method, the peak pulse amplitude is treated as MAP, which is mean arterial pressure. And that gets normalized to a value of 100%. So that's going to be your highest pressure, right? The cuff then, the cuff pressure at MAP is then the MAP pressure. So 100% is MAP. So we have systole and diastole, right? And they are fixed percentages based on MAP. So you'll see that they are going to be percentage of MAP. The cuff pressure under diastole is the diastolic pressure, and the cuff pressure under systole is the systolic pressure.
And
right?
these are calculations and they are statistics. They're based on
Right.
statistics. So it gets ghosty in terms of, you know, can you absolutely count on this? This is at a high level trying to explain how this height method works. Just think of it as a statistical method of coming up with a measurement.
Right, and there's no standard, right, to suggest what those percentages should be, right?
Correct. Yeah.
If they should be fixed or variable, whatever they should be. Basically, manufacturers that are using this height-based algorithm, they've done their own clinical trials and drawn their own conclusions about what that percentage should be, and whether they're fixed as a function of MAP or not. So again, this is based on clinical data for manufacturers that are using the height-based algorithm. And then we'll jump into the second one, which is the slope method. And you know, there are many methods that are used to determine how many slopes should be drawn here and what conclusions can be made about their intersections. Because as you can see, those straight lines are the slopes and their intersections are where the measurement point's going to be. So as shown in the figure, you know, the cuff pressure under the intersection of the slopes is treated as the systolic and diastolic pressures. Again, there's no standard here for slope algorithms. Same thing as with height algorithms. But essentially, it measures those slopes and their intersection to determine where systolic and diastolic pressures lie in relation to MAP.
Yep, and this is actually a calculus math that's done. Point slope is calculus. And so we use calculus to measure things that are messy. They don't have square corners and stuff like that. So this definitely does not have a square corner. So the slope method, think of it as the calculus way. And by the way, the manufacturers of NIBP don't tell you which they're using.
No, but it is good to understand that it's one or the other here. And that there is no standard, but the manufacturers have figured out which one to use and how to use it, and that it works for their device. But it is good to know that, yeah, there are two different methods here, and this is how, you know, any particular system will likely be measuring the two pressures. Okay. So we don't want to get into any more detail than that to get it more fuzzy, just so you guys know that there's something working in the background there. So the other thing is that when an NIBP monitor is made, right, whether it be a patient monitor, a nurse on wheels, standalone NIBP monitor, they have to make sure that that parameter is safe and effective for use in the diagnosis and treatment of disease states and underlying chronic conditions, right? And in the prescribing of medications and other therapies. So again, it's in the diagnosis and the treatment. So this testing is governed by the national and international standards for minimum performance and safety. So here you can see that we have, you know, AMI ANSI SP10 or IEC 60601-1-2-30. There are multiple others as well, but they are governed, right? So the performance of NIBP monitors are required to be evaluated or tested during scheduled maintenance by the manufacturer, right? And basically what happens is this performance testing is detailed in their recommended test procedure, which is going to be found in the service manual for that particular brand and model of patient monitor. So again, what the manufacturer has determined needs to be tested gets passed on to you in the service manual, and that is to be followed in a scheduled maintenance period to make sure that that NIBP monitor is able to be tested, used on the next patient for either diagnosis or treatment. Anything to add there, Jerry?
No, I mean, we're going to cover a little bit more depth there in a couple of slides, but that's very well stated. So really kind of no shortcuts. The manufacturer's test procedure from the brand and model specific service manual is the one you should be following. If you can't get a hold of that, then you need to create one that, or use the tests from the international standard. The AMI-ANSI SP10 for the United States has been harmonized, and that means made to match the IEC 60601-2-30. So that's the right way to approach it when you're trying to set up the test procedures, especially if you're using an alternative preventive maintenance scheduling program.
Perfect. Yeah, so knowing that now we have to do testing, the next poll question is going to jump into how we do that testing, and I'll tee that up. So how do you test NIBP devices for accuracy? So is it A, by doing a static pressure test, B, by doing a dynamic simulator test, or C, by performing a visual inspection? So why don't we kick that poll question off and see what comes in.
All right, the poll has been launched. All right, we're about halfway there. We have about 56 voted % of the group here, so get your vote in there. Two of these are favored pretty equally. So
Okay. Curious to see what they are.
give you guys about 5 more seconds, and then we'll close the poll and show. All right, I'm going to close the poll and share the results. So we have 51% by doing a static pressure test, and then 47% by doing a dynamic simulator test, and then 2% a visual inspection.
All right, neck and neck. So let me reveal the right answer, which is doing a static pressure test. So again, yes, Jerry will jump into this in a bit more detail in a second, but when you're testing an NIBP device for accuracy, you can only do that using a static pressure test. And I won't steal Jerry's thunder. Instead, I will just move on to the next slide.
I'm laughing because Mike and I talk about this so much. So static pressure test, as Mike said, is the only way to properly assess accuracy of the measurements made by an NIBP device. Any device, whether it's automated NIBP or whether it's the fluid-filled or mercury sphygmomanometer or the sphygmomanometer gauge, the aneroid gauge. It doesn't matter. The only way to verify it is to do static pressure levels. And as I said earlier, that requires you to be in the service mode of the NIBP device. So you've got to be sure that you're able to get in there and do that, because you have to control the pressure relief valve in order to seal the vessel, the measurement vessel, and pressurize it. So that is supported by the International Organization of Legal Metrology, that has everything to do about making traceable measurements for standardizing how we measure no matter where in the world we are. So it's really important that we understand this is coming down to us from very credible sources. It's an international agreement that is signed on to by many, many countries, and new countries are signing on to that international agreement every single year. And the United States has long been a signer onto that agreement. So that's the only way to measure accuracy. Now, that doesn't mean you don't want to do dynamic simulation. That's fine, but dynamic simulation cannot tell you anything about accuracy. It simply cannot. We are sending a dynamic pressure signal into the front end of the patient monitor when we're doing dynamic simulation. And the monitor still has to pick the right pressure in the cuff. If it doesn't, then the measurement is going to look very strange. It's not going to be what you expect. So it's really, really important to, dynamic simulation wants to look like it's just the same thing as the clinician's going to do when they use the NIBP device, and it kind of is, but it's not able to tell you about accuracy. What it does tell you about is repeatability. So if I send a dynamic pressure signal into the front end of the monitor that should be 120/80, no matter what's displayed on the patient monitor, no matter where it picked the pressure in the cuff and what it displays, if it does that every time I send that 120/80 signal, then I have repeatability. Is it accurate? It may not be. Is it precise? Could be, okay? So precision and accuracy are things that we want both in our measurement, but dynamic simulation can only give you the precision measurement. It can't really tell you anything about accuracy. So I want you to get out of your mind that dynamic simulation is the only test you need to do to measure objective and get objective evidence about the accuracy of an NIBP device, because it just cannot happen. There's too many things that are changing all at the same time, and you can't make a credible, traceable measurement if you can't control all the variables, which is the problem with dynamic simulation. But it's a good test to be able to run, a very good test to be able to run, but it's about repeatability. So now we have the two: accuracy with static pressure, repeatability with dynamic simulation.
So do you want to double click on that, Jerry? Just
Yep,
hit
sure.
hit one more time on what accuracy is and what repeatability is.
So here's what the International Order of Legal Metrology, OIML, why is it that way and not, it's because it's French, okay? OIML is the French abbreviation of this organization. And they made this comment a while back, 2002, about NIBP. For NIBP device, non-invasive devices, an NIB patient simulator is not to be used for testing accuracy, but is required in assessing the stability of performance, i.e. the repeatability of the tests. So this is coming to us from this international group, from the part of it called legal metrology, which helps us understand traceabilities and the proper way of doing measurements. And they're saying to us, dynamic simulation is not a way to do accuracy, period. And it further states, this group further states that it places limits on the variability of the simulator itself. So think about this when you're thinking about which simulator you're going to buy. Additional deviations originating from the simulator of not more than 0.27 kPa, that's about 2 millimeters of mercury, for the mean value of the measurements, and generating signals of blood pressure values approximately systolic 120/80 or diastolic 120 and diastolic of 80 with a pulse rate of 70 to 80 beats per minute. That is the key test point, but it's a simulation, the dynamic simulation that they're talking about here. And as we said before, the important part about whether what shows up on the NIBP monitor display is all about, did that system pick the right peak pressure in the cuff, yes or no? If it didn't, then the measurement that it displays is going to be quite different than the information that you're sending in the dynamic simulation, okay? Accuracy, static pressure level comparisons. Dynamic simulation, repeatability, period.
Perfect, thanks, Jerry. So moving on to testing NIBP accuracy. How do we test it, Jerry?
All right, so we must be in the patient monitor service mode for NIBP and for calibrating that system. So calibration is, first of all, making the measurement and comparing against the tolerances, that is the plus and minus values. And if it's out of tolerance, it stops, it failed the calibration, and then you got to do something. You got to take a corrective action. So make sure you understand calibration is about the measurement, okay? The patient monitor may need to be the pressure source. So it may not be able to be the simulator, for example, ProSim 8, doing static pressure tests. We can make the ProSim 8 be the source of the pressure. But most of the NIBP systems that I have looked at over these last 40 plus years of my experience, the NIBP device itself wants to be the pressure source. So fine. Then we just use our simulator as a very accurate pressure meter to be able to make sure that we see the pressure that we're sending, right? And we have something credible and traceable, by the way, when you keep your simulator calibrated, traceable when we're comparing what we see on the NIBP display versus what we see on the display screen. So the pass-fail will be specified by the patient monitor service manual, NIBP calibration section. And if it fails the test, the NIBP calibration section will also give instructions about what corrective action you could take. Can you make an adjustment to that system that allows it to come back into tolerance for pass-fail? If it doesn't, it may have to be a corrective action or repair by replacement of that NIBP module or subassembly. So there's all of these things that you want to consider. But this is how you want to think in general terms about how you're going to test NIBP accuracy. And if your simulator cannot also be your digital pressure meter, well, that may tell you something about whether that simulator, where you're getting the value that you really want to have.
All right, same question on repeatability.
So kind of the same thing here. Again, as I said before, we're sending a known pressure signal into the front end of this NIBP device. We know what the peak pressure that the device should find is. But if the device itself, if its algorithm is not picking the right peak pressure in the cuff, then the measurement that it displays is going to be incorrect. Why? Because it didn't pick the right peak pressure to either statistically calculate what the mean or what the diastolic and systolic pressure is, or it didn't calculate by the slope method what those specific points where systolic and diastolic occur. Because automated NIBP always produces the mean arterial pressure, that is the highest pressure that you're supposed to be sending in the cuff, okay? So repeatability depends first and foremost on the monitor picking the right pressure that's being sent to it, okay? So so what have we done? So this is just talking about ProSim 8 and ProSim 8 in particular, okay? And what we did to help you always be able to get a good repeatability test. So as I said, both methods, height or slope method, pick the mean or highest pressure in the cuff. And we need to help it sometimes find what is the proper one that we're sending, especially with ProSim 8. So one way that we can help that is with a little bit of a shift in where that peak pressure is going to occur. That is the peak pressure that we're sending. Okay, so so this shows you a little bit about shift left or shift right, and you have controls for that in the ProSim 8. Okay, so I think, Mike, we have another slide on that.
We don't. We just have
okay.
NIBP performance testing.
Right. Yep. So this is called envelope shift. Yeah, it's called the function in the ProSim 8 is called envelope shift, And remember, we're not worried about accuracy. We're worried about repeatability. And what we'd like to see is to try and understand how this NIBP device is picking the pressure in the cuff. So what we're going to do in the signal that we send is we're going to shift it left or shift it right a little bit to help the monitor come up with the same or close to the same pressurizations that we're sending with our simulator. Okay, and that's what envelope shift is about. It's not a cheat. It's not about accuracy. It's about helping understand the repeatability and what's going on in this particular brand and model of NIBP device. It's just another little functionality that helps you get measurements that seem better for you.
All right, so how can we automate this testing, Jerry?
So it turns out that since you can use a test automation software or test automation system. Now we have provided test automation since before the year 2000. Whether we have interoperability between software to automate with and our test instrument, our simulator, or not, we can automate the testing and make it very efficient. Okay, so we have the ability to do that in two softwares that we had, our older software called Answer, and now the new software called OneQA. So right now we would create this efficient, but not necessarily quite yet interoperable way of making the measurement. But we also have auto sequences already built in to the ProSim 8 and, by the way, into ProSim 4. Those are our two simulators that are able to produce an NIBP signal. They're both able to measure static pressure, so we can get the accuracy, but they're also both able to send the dynamic simulation, and it sends it on the base with other patient parameters, so that everything comes to the monitor, including NIBP, as if it were coming from a real life patient. And we're sending classic textbook groupings of signals. So based on high blood pressure, normal blood pressure, or low blood pressure, hypertension, normal, and hypotension. So we're able to run 3 simulations to make sure that we have that. And those auto sequences are built in and selectable right from the front panel screen of ProSim 4 or ProSim 8. So you're going to want to have a look at that. Maybe you're going to want a demo if you don't have a ProSim 4 or a ProSim 8, and have a look at how that kind of works. We might even use that auto sequence in an instruction in either Answer test automation software or in OneQA to instruct you what to do in setting up the patient simulator in order to make the appropriate test. So why is that important? Well, if we just use the onboard automation, the problem is we have measurements that we can store as kind of a test report, but they're only about what the simulator can do. They're not about what anything else that we need. If we needed electrical safety or if we needed something else, it will only give us that little sample test report for what that test instrument can do. If we use either of the two softwares, what we get at the end of the day is the ability to set up the entire workflow: visual inspection, leak test, electrical safety test, accuracy test. Okay, all of those things can be set up in a workflow that result in a single complete test report that you can either then save, turn into a PDF, and append to your work assignment from your CMMS, or in some cases, if there's an interoperability between the software, Answer or OneQA, and the CMMS, it will automatically pull in the appropriate criteria and result. and give you the ability to append to that work assignment the pass or the fail with the evidence of the test result report. Okay, so those are ways that you can automate this. And you know what? Compared to pen and paper, or compared to a spreadsheet on your computer or something, or just a simple checklist, the checklist doesn't give you the ability to mine information about failure rates. And failure rates are really important in order to get to predictive maintenance. That is, when I start seeing a trend that's looking like it's going too high or too low, I can take action before the actual clinical failure or failure during clinical use. And that's really what we want, because why? It makes the doctor's diagnosis or assessment of treatment better and reduces the risk of injury to the patient, keeps their length of stay appropriately short, so the patient goes home well sooner, and so the hospital makes money, so we get paid.
Perfect, Jerry. All right, I noticed that we have 5-6 minutes left. I do want to jump to Q&A to make sure we get some of those questions answered, but thank you all for joining us for the educational portion of this. Not that the questions won't be, but yeah, let's open up the floor to questions. And before we do, just want to say, if you wanted to learn more, we do have the Fluke Biomedical Advantage Training Center, which is free on-demand online trainings. So do sign up through our Knowledge Center and see the variety of courses we have there to learn more, not just about NIBP testing, but all the types of testing that you guys are asked to do in your day-to-day. So with that, we'll jump over to Q&A.
All right, we have several questions that we got from our audience today. So one of the questions is, how do you find out the envelope ships for different brands of vital signs monitors so we get accurate readings when testing?
Wonderful. We actually published a app note that explains how to arrive at shift left or shift right. You have to do it by experimentation, because each brand and each model within a brand of NIBP can be different. Why? Because the algorithms end up being different, even if they're always height or even if they're always slope method. So there's no way for us to give you a concrete identification of what that is. You have to arrive at it experimentally, but we explain in that app note how to do the experiment. And that way you can come up with your own shift left or shift right. You can add that to your test procedure for that specific brand and model of NIBP.
All right, thank you, Jerry. The next question is, okay, so we touched on that a little bit in the presentation, but let's elaborate. How do you respond to a clinician who wants their sphygmomanometers to match their NIBPs, or those that question the differences in readings they obtain from each?
Well, we have to sit down with them and explain to them that the automated NIBP is based on the manufacturer's, a lot of manufacturer choices and data that is both technology specific in terms of the design and the software algorithm, but also the software algorithm has been customized to the clinical studies that were done by that manufacturer, okay? So it can be different than the auscultated readings that you take with an aneroid sphygmomanometer or a liquid column sphygmomanometer. They can just be different. Also, how do we address the variable of hand-eye or ear-hand coordination in terms of picking the Korotkov sound, the pressure at which the Korotkov sounds happened? I had this problem with a phlebotomist in our clinical laboratory who needed to take blood pressure measurements but couldn't hear worth a damn. Just never could. And so what this person would do is estimate. Yeah, I think it was this. And that's what they would write down on the patient's record. Oh my gosh. Okay. That's not okay. So there are a lot of variables. So they may not agree exactly ipsy perfectly, but that's okay. They should be relatively the same, okay? But there could be variations. There absolutely can. And you just got to understand the technologies and the different technologies and how they actually make their measurement. And don't forget to add in the variable called the human being clinician that's actually auscultating the reading. Okay.
All right.
Next.
Sorry, it took me a second to unmute myself. All right. So next question is, why MAP is needed to be measured?
It turns out that when you look at the clinical studies, the mean arterial pressure is actually a much better indicator of cardiovascular health and the health of the blood vessels, and assessing and watching over a treatment plan period of time the changes in blood pressure based on whatever the treatment is that we're trying to do to the patient. So many times, and especially in anesthesia, for example, it's the mean arterial pressure that the clinician is looking at much more than the systolic and diastolic. Not all patient monitors display the mean arterial pressure, or in some cases you may have to turn that on so that it's displayed on the screen. So there are some dependencies in the design of the patient monitor and the NIBP portion of it and how it gets displayed. But the mean arterial pressure tends to be the most stable. It's the one that the clinician can usually depend on the most, no matter whether they feel like the systolic and diastolic accuracy is where they expected it to be.
And I think with that, we're actually at time. So we'll have to wrap up our webinar. Thank you all very much for attending. We will try and get back to you, to all of you who asked us questions in the questions section but did not get their answers because we're so constrained in time and we have so many viewers in our event. But we do encourage you to come and discover our free educational resources such as our Advantage training and webinars available on flukebiomedical.com. I hope you all have a great day. Thank you, Jerry. Thank you, Michael. And we will see you in the next webinar.
Thanks, everybody.
Thank you all for joining.